You know, when we think about global warming, we picture a one-way street, right? Just a hotter and hotter planet. But what if I told you it could actually trigger the exact opposite? Yeah, some pretty wild new research has uncovered a shocking twist in Earth's climate story. A link between a warming planet and, get this, the start of a new ice age. Let's dive in.
It sounds totally backwards, doesn't it? How on Earth can a hotter planet possibly kickstart a global freeze? I mean, for years, this has been a real head-scratcher for scientists. But now, it looks like they might have finally found the missing piece of our planet's climate puzzle.
So to really get our heads around this paradox, we first have to look at the old theory. You know, the one that scientists at UC Riverside just kind of turned on its head. For decades, the way we thought about Earth's climate control system was all based on one central idea. For a very long time, the thinking was that Earth has this sort of natural thermostat, a slow, steady, super reliable system that keeps temperatures from going completely off the rails, you know? It keeps our planet in that perfect Goldilocks zone for life. Okay, so let's take a look at how this thermostat was supposed to work. This whole established theory is based on a process that's, well, as old as the hills themselves, literally. It's all about the slow, grinding breakdown of rocks. The process is called rock weathering, and it's actually a beautifully simple feedback loop. The idea is, as the planet warms up, this weathering process speeds up, which pulls more CO2 out of the atmosphere, and that gently taps the brakes on the climate. It's supposed to be Earth's slow, steady, self-correcting system. Here's the play-by-play. Rain sucks up CO2 from the air, which makes it slightly acidic. Then that rain falls on certain kinds of rocks and dissolves them. That carbon-filled water eventually makes its way to the ocean, where the carbon forms limestone and gets buried on the seafloor for millions of years. Slow, steady, predictable, or so we thought. But there's a really big problem with this story. And the problem is, when we look deep into Earth's history, the story we find isn't one of gentle stability at all. It's a story of extreme, absolutely wild climate swings that this simple model just can't explain. So here's where things just don't line up. On one hand, you have this tidy little theory about a gentle, self-correcting thermostat. But on the other hand, you've got hard evidence of these snowball Earth events. We're talking ice ages so intense, they basically turn the entire globe into a giant snowball. A gentle thermostat does not create a snowball planet. The two just don't add up.
Right, so this is the million-dollar question that got researchers looking for something else. If that rock-weathering thermostat was doing its job, these insane deep freezes should never have happened. Something else had to be going on, another, much more powerful force that could push the climate right over the edge. And that brings us to the breakthrough. The research team found this powerful and kind of overlooked factor. It wasn't happening on land, but out in the ocean. And it's a biological process that can work way, way faster than the slow grind of geology. So it all starts with warming. As the planet heats up, you get more rainfall, which washes more nutrients like phosphorus from the land into the ocean. This basically fertilizes the sea, triggering these massive blooms of tiny plankton. And just like plants, they breathe in CO2. But here's the key. When they die, they sink, taking all that carbon with them and burying it deep on the ocean floor. But here's the crazy twist. This ocean process doesn't just cool the planet. Under the right conditions, it can spiral completely out of control. It creates this powerful feedback loop that doesn't just tap the brakes on warming, it absolutely slams them to the floor. Okay, so the key ingredient here is oxygen. As these enormous plankton blooms die off and decay, that whole process uses up a ton of oxygen in the seawater, creating these huge low-oxygen zones. And this is where the system just goes haywire. This is the runaway cycle. In these low-oxygen areas, the seafloor starts releasing even more phosphorus. That extra phosphorus fuels even bigger plankton blooms, which then die, decay, and create even larger low-oxygen zones. You see where this is going? It's a vicious cycle that just rips incredible amounts of carbon out of the atmosphere, causing global temperatures to totally plummet. One of the researchers, Andy Ridgwell, came up with the perfect analogy for this. He said it's like having a thermostat that's not placed close enough to your air conditioner. It correctly senses the house is getting hot and kicks on the AC, but then it completely overcorrects, making the house way, way colder than you wanted before it finally shuts off. That's how ancient Earth could overshoot so dramatically and plunge itself into a deep freeze. So, of course, the big question is, could this happen again? I mean, does this ancient climate switch have any relevance for us today?
as we're pumping CO2 into the air like never before? Let's take a look.
The key difference between then and now really comes down to one thing: oxygen. Earth's ancient atmosphere had way lower oxygen levels, which made this whole feedback loop dangerously unstable, or wobbly. Today, our oxygen-rich atmosphere acts as a stabilizer. To use that great analogy again, the thermostat is now closer to the AC unit, which makes it much less likely to overshoot like that.
And it is absolutely critical to understand the timescale we are talking about here. These are geological and oceanic processes that play out over tens of thousands of years. This is not some quick fix that happens over a few decades or even a few centuries. So let's be crystal clear. This natural cooling mechanism is not going to ride in and save us from our current climate crisis. The warming that we are causing is happening way too fast, and the Earth's natural rebound, however powerful, is not going to happen quickly enough to help us.
Ultimately, this research is just an incredible window into how our planet's complex machinery works. It proves that, yes, Earth will eventually rebalance itself. But the critical question has never been if the planet will cool down on its own. It's always been when. And this discovery really confirms the answer. It won't be nearly fast enough to matter for us.